Hey everybody, it's Andrew Brown from the AWS Cloud Project Bootcamp. And so I just started to read more about Werkzeug. And actually when I say read, I asked ChatGPT, so, why should you not use, because I just couldn't find the exact reasons why you should not use for production use. Class server, Python web server for production use. And then we'll see what we, I wrote user. Let's fix that. Please only one time, please allow any other response to complete before. Well, it's not going to complete now. We'll refresh this here. We'll try again. Okay, we'll just switch over to ChatGPT 3. Anyway, I did ask it on my other computer here, so maybe I can find it. And maybe I can screenshot it and bring it over. Okay, and so what I did is I just went over to the Discord, which apparently I have over here, and I'm just going to pull it up so that we can just take a look at it, okay? It was just easier to screenshot it on my other computer, so I'm just looking for it here off topic. And so I posted this, and everyone's going to be like, why'd you post this, Andrew? So this here says, Werkzeug, sorry, I don't know how to pronounce that, is designed to be a development server primarily for development purposes with built-in development server. It's not used for production server. So that, number one, doesn't tell us much. Security concerns. Does not provide built-in security features that are critical for production server. So it does not include SSL, TLS. Okay, we don't need that because we are going to be terminating it at the load balancer. So we don't need TLS. So the one security concern listed, not a real security concern because we're pushing that to the cloud on cloud services. And that's what you want to do when you're using containers. Limited scalability. The built-in development server is single-threaded, meaning it can only handle one request at a time. This is not suitable for production environments where high levels of concurrency are needed to handle a large number of requests. This is dependent on the way our stuff is set up. So I think the way it works is that for each vCPU, you can only have a certain amount of hyperthreads. If you don't know what hyperthreads are, let's see if I can get an example one. Hyperthreads. Compute. And let's see if we can get something for an image here. So the way hyperthreading works is that it can load up stuff. Let's see if I can get this one image larger here. And I'm going to bastardize this explanation, but I mean, it will still kind of work for what we're doing. So the idea is that when you have a core, you can load up your instructions into here, and then it will go and go through the stuff and parse your information. So usually when you want to have more threads, you need more cores. So that is the advantage of having multiple cores. Now you can have a single processor that is hyper-threaded, meaning you can queue up more stuff, but it's still using a single core. And so it's not as, like, this is a lot more efficient having multiple cores, but this is still more efficient than having a single core. So the idea is that it might not be 2 times more efficient. It might be like 1.25, 1 point whatever per core that you have. But my point is that it is more optimal to have hyperthreading. And so when we're using vCPUs, I'm pretty sure that they give you a certain amount of hyperthreads. How many hyperthreads per core vCPU for Fargate? Okay, I apologize for that. I didn't provide a good explanation, but here it's being suggested there are 4. Let's take a check here and see if this is accurate. This has a downvote of -1. Doesn't give you a lot of confidence, but here it says you can have a max of 4 hyperthreads. So I don't really know how many threads we can have, because that's what really matters. Because if it's single-threaded and you can only have a single thread, it doesn't matter, right? So that's what we're trying to get at here. So one vCPU instance does not simultaneously share cores with other customer instances. A core can be sequential, time slice, stuff like that. So I'm just trying to figure out how many threads do I get, because I don't know. That's my problem. I'm not sure. I scheduled a micro instance particular, so I'm just trying to find any information about that. So does one vCPU equal one hyperthread? That's really what we're trying to find out. Does not sometimes share cores with other customers via the inter-hyper-threading technology. A core can be sequentially time sliced between customer instances when you are using a fractional M3 medium or T2 instance. Includes a, I don't know why I can't increase. I'm trying to increase the size of this page here, but it's acting kind of weird for some weird reason. Yeah, I guess it's just not responsive on Hacker News, so I can't increase the font here. I apologize. It's really weird. Refresh the page to kind of do it now. Oh, I had to refresh. Okay, so does one vCPU equal one vCPU? And this is 2018. If I schedule a micro instance in a particular zone and nothing else for the duration of my time slice, the VM will have to monopolize the core. Optimal use of the vCPU would demand that 2 VM threads get scheduled. Google says it won't. Time slicing doesn't solve this problem. Imagine a machine with 8 cores and 16 hyperthreads. Now you need to optimize it. So I'm not sure what it means. So this is what matters. Like, if we don't know like how the threading works, it won't matter if we use GUnicorn. Okay, so that's another consideration that matters. And so that was the thing about concurrency and scale. Now, if we had long-running tasks, we shouldn't be necessarily running them in our application. Like in our Flask app, they would be their own containers running as tasks, and that would free up that issue as well. So again, that is not a problem. It says many production features that are essential for production servers, such as process management, logging, and performance monitoring. Well, you run one process per container, so what's this process management that we need that is so complex? We really don't. And if an issue happens, a health check will happen, it'll shut it down, spin it back up. Logging, yeah, logging could be a little bit better by default, but we are able to plug in our own logging. So maybe GUnicorn might give us like a standard logging format that might be an advantage to us, but we could also probably manually install that ourselves. Like maybe there's a plugin for that and we get a nicer logging per request. But we can instrument our applications, and it wasn't that hard to do. So there's that option as well. And then we have performance monitoring. We don't really need to monitor performance if it's a single process on a container. We can get all that information maybe with container insights, or even just when we're in Fargate, we were getting information about memory and other usage there. So I don't see a problem other than maybe the threading. If we could better understand how vCPUs use threading, maybe it would make sense to run GUnicorn if we're launching more than one vCPU. And we're not even using one vCPU, we're using a fraction of a one. So again, I just wanted to make this really clear. I was considering going and setting up GUnicorn if we discovered something here, but I don't know. So I really do need to have a better reason for it. And I just wanted to be very clear, not just say, I don't have confidence as to why. Now I have more confidence to say why it's okay the way we're doing it. So there you go.